Okay, welcome back to R. Let's get started. So I'm going to run my first line of code that I always run to clear the workspace. And for today, we're going to talk about more data structures. Specifically, we'll talk about data frames, factors, and lists. Okay, let's go over our notes for data frames. So data frames are a lot like matrices in that they are rectangular, except for the main difference is the columns can have different modes. So we can have character modes in one column and numeric modes in another column. So this makes them flexible enough to be the fundamental structure of most R's modeling software. That is, we can now have categorical and continuous data saved into one object. I want to point out off the bat that newer versions of R no longer coerce factors or character variables. They no longer coerce characters into factors. You can change this and might want to do this by running this line of code, options strings as factors equals true. And you'll learn about what a factor and a character is in a moment. Okay, so go back and look at this after we learn about that. So here's the pseudocode. You're going to want to use data.frame. We'll create a data frame, and you'll have the variable 1 already saved as variable 1, and it'll have a nice name. Variable 2 will be saved as variable 2, and it'll have a nice name. This code here, my.data.frame of 1, will go back and get just the data for variable 1, so it will return that vector of data for variable 1. You can also say my.data.frame string or $ variable 1 to do the exact same thing. A useful tip is if you run attach of my.data.frame, whatever your data frame is named, then you can refer to variable 1 directly without having to do my.data.frame bracket 1 or my.data.frame string variable 1. Let's look at an example. And the first thing you're always going to want to do is read the help file. So you'll say the first thing you have to do is give it some information, and here's how you can do row names. And here, strings as factors equals false. You'll want to use strings as factors equal true if you want your character variables coerced into a factor, which makes sense in a lot of data analysis, but not in other settings. So let's look at how we would use data frames. So here I have a variable scores containing values 85, 80, and 95. This will be a numeric vector. And now I have this guy grade. This is my another variable. And this is character because you see the quotes. So now if I do gradebook, I would use data.frame and then just list scores, comma, grade. And that will create a data frame that looks like this. Here I have scores, and now I have grades. So I am allowed numeric and categorical data to be saved in a data frame. And if you look at mode of gradebook, it's going to tell you it's a list. Well, a specific type of list is actually a data frame. So just like a specific type of an array is a matrix, a specific type of list is a data frame, and that's okay. If you type class, it'll tell you that this belongs to data frame. Okay, so a function that you usually want to apply to any object is called structure str, and that will tell you that I have a data frame that contains 3 observations for each of 2 variables. It will tell you the first variable is called scores, and it's numeric, and these are its values. And if there's a bunch of values, it'll just have ... And it'll tell you the second one is a variable called grade, and it is a character variable with these characters. And like I mentioned, double bracket 1 of gradebook will just pick off the first variable. I could also do gradebook string scores to pick off the first variable. And you'll notice that is just a vector who has a numeric vector with values 85, 80, and 90 if I run structure of just that vector. If I wanted to pick off that vector, say if I ran gradebook of 1, like up here, I would get a vector 85, 80, 90. Okay, so this code here gets that vector. This code says, now look into that vector and only pick off the first and third elements, and that's what it did, 85, 95. Okay? Instead of this bracket, bracket 1, I could have used gradebook string scores and then have this bracket to say, go get the first and third score. Okay? Likewise, instead of the first and third, I could just ask it to return the second score. Okay? Now, if you look at each individual vector, vectors must have the same storage mode, and it's going to tell you that the scores vector is in fact numeric. And if you look at the grade vector, it tells you it's a character vector. So indeed, each vector has different storage modes or belongs to a different class. So an IRIS data set, you'll notice if you look at most data sets in R, it'll tell you a lot about this data set, but it'll tell you it has 50 flowers for each, and it has species. So it'll say iris is a data frame with 150 cases or rows and 5 variables: sepal length, sepal width, petal width, and species. And species is going to be a factor or a character. So here's what the iris data set looks like. Here I have my sepal length for the first iris plant was 5.1, sepal width was 3.5, and petal length was 1.4, and petal width was 0.2, and I recorded that it was from the Setosa species. Now the nice thing about data frames is that a lot of functions in R are made specifically to work with data frames, more so than they are with matrices. So if I run plot of iris, it knows that that's a data frame, and it will give me this plot of all of the different variables. So here you'll see sepal length and sepal width are plotted, but sepal length versus petal length are plotted up here. So think about this as a matrix. Petal length intersects with sepal length here, so petal length on the x-axis, sepal length on the y-axis here, and so on. And you see species does not mean a lot here. We wouldn't usually have these plots for species. But nonetheless, you can think of species 1, observe it had petal width down here. Species 2, these are the petal widths. Species 3, these are the petal widths. We would probably do a box plot of these in practice. If I run summary of iris, it'll give me my 5-number summary plus the mean for each variable if this is saved as a data frame. And it also has my species. It just gives me counts. I had 50 setosas, 50 versicolors, 50 virginica. So it knows not to take the average of this categorical variable. It knows now to record the frequencies of those categories. Okay, now let's look some more about how we refer to different parts of iris. So this is going to say get variables 1 through 3. Here I just have bracket variables 1 through 3, and then rows 1 through 2. And that's exactly what I got here. Here, rows 1 through 2, comma, columns 1 through 3. So you can use matrix syntax to refer to elements of a data frame as well. So lots of ways to refer to elements of a data frame. Now let's look at what the attach function does. So I might want to just look at species. So remember, species is a variable inside my data frame, but R doesn't know to look inside the data frame iris for species. And so I could either do species or iris string species. This is probably what I want. R just didn't know to look inside the iris data set. So if I just type species, R doesn't know where to find it. If I run attach of the data set now, it will know, it will find species. Okay? And you're going to want to run detach when you're done. Otherwise, you can attach things over the top of other objects in your workspace. So when you detach it, again, now it can't find species. All right, what are factors? Categorical variables, at least if you're analyzing categorical variables, are going to be saved as factors. And factors can be nominal or ordinal, so they can be ordered. They belong to the same class, and so factors belong to the class factor and have numeric mode. Data frame can coerce character variables into factors automatically. So you'll need to use the strings as factors equals true argument again if you want to do that. Or change the default setting that we talked about above up here. Run this line of code. Okay, back to factors. So here's the pseudocode. I'm just going to run factor and then my variable name, and if variable is categorical or a character, if this is a character vector, it will coerce this into a factor. So here's an example. Suppose I have, so first read the help file, and you can see that it wants input character vector, and then we can specify levels as well. We'll get to that later. So, fertilizer. This is a character vector, so quote L doesn't mean much in terms of analyzing data. What you really want to know is L is a level of the variable fertilizer. Okay? And again, if I run summary of a character variable, it's not going to know what to do with it. It's just going to say I have 6 characters. But as far as R is concerned, it doesn't know what to do with anything that's in a quote. So now, if I coerce fertilizer into a factor, suppose I run this code, this is altogether different than this guy, right? So factor of the character vector is an entirely different object. And if I run summary of that factor, now it says, oh, okay, I had levels high, low, and medium, and there were 2 high levels, 2 low levels, 2 medium levels. So now summary knows what to do with a factor. So let's look at some more data. Suppose I have yields, and I wanted to have, so suppose I had yields of my first field was 30, and I have also my fertilizer was low for my first field. So I might want to store this data as a data frame, and this is how I would do it. Data.frame, fertilizer yield. And now you'll look and see that I have this guy. Fertilizer for the first field was low and the yield was 30. Second field was medium and the yield was 40, and so on. And if I run summary of ag data, it will say still fertilizer, it gives me this, it still says that this is a character. So it did some nice work on my yield variable, but for my fertilizer data, it didn't know what to do. So I might actually want to either change my fertilizer variable into a factor and just work with that from here on out by running factor of fertilizer. So now I have this guy. And if I run data.frame, of fert.factor and yield. Fert.fact. Now this is a factor, and if I run summary of that, it should work much better. Okay, so that's again new to this version of R, or to recent versions of R. All right, back to the notes. Fert.factor, what I said a minute ago, convert it to a factor. Well, what if I want to make sure that this is an ordered factor? So you'll notice here I have levels, high, low, medium, but really I have low is less than medium is less than high. And so how do I take that into account? I would say factor, here's my character variables, and now I have to say, here's my character vector fertilizer, and I have to say order equals T or true, levels low, medium, and high, and it will order them now in that way. So now my ordered factor says, yes, I have low, medium, high, low, medium, but it also knows that I have low is less than medium is less than high. So you'll notice if I run a box plot of yield by my fertilizer factor, it doesn't know that these guys are ordered. But if I run, so you'll see I have a box plot for my high group, then the low, then the medium. That's probably not how you would present that box plot. How you would probably present it is box plot of yield by my ordered factors. And now it will put low, medium, and high in order on the x-axis. Okay? Didn't create that. Now it's there. Okay? And again, after you've created a data frame, it's always a good idea to run structure. Now you'll notice I've created this data frame where fertilizer.ordered factor is an ordered factor. So it was originally a character, then it was a factor, now it's an ordered factor. Okay? And so it even tells me low, medium, and high. So lots of ways to handle a character vector inside of a data frame. Okay, now let's talk about lists. Lists have almost no structure, so they don't have to be in an array or anything like that. They can be composed of objects, and lists can have lists inside of themselves. So let's look at this pseudocode. How I would create a list is I would do list, my name for my first element of my list, and then tell it the object. And so this could be a data set or a variable, whatever I want it to be. Okay, so how would I refer to elements of a list? So object 1 is saved in the first element. So if I run my.list, double bracket 1, it will give me the first object in that list. I could also do my.list string name1. So much like a data frame. So let's see how we would use a list. So let's suppose I create these ag summaries, which is the summary of my ordered ag data where I used it, where I assume the factor was ordered. So I have some ag summaries, and if I run this, I have my original ordered ag data, and then I have the second element of my list contains the summaries where I ran these summaries. So I create this object ag summaries. I already have my ordered ag data, so now I have a new list that contains information. The first element of the list is the ordered ag data. The second element is the summaries of them. And so you'll see here, ag information, string ag data. This is my original data. I applied the summary function to it, saved that as ag summaries, and now, I named, and I added those as a second element of my list, named them ag summary here. And so now I have my original data, summaries of each variables. So very useful if you want to store a bunch of differently processed information with hardly any structure. So again, how would I just return to my data set? I would just use double bracket 1. First element of my list is just the original data. I could also use string ag data. Okay, so we talked about data frames, factors, and lists. So data frames can contain categorical variables and quantitative variables. Categorical variables can be saved as factors or ordered factors instead of just character vectors. So data frames can also allow for the categorical data to be saved as any of those. So I could have a data frame with a character vector, it could be a factor, and it could be an ordered factor. and then it can also contain numeric values, and it can contain true, false logical values as well. And then lists are really useful. They are even less structured than data frames. They can contain a data set, summaries of data set, almost anything.